placing fuel metering and timing into a single rebuildable component. Most importantly, the entire system was designed to be repaired anywhere, not optimized in a laboratory. Every major component could be rebuilt with standard machine shop equipment. The design allowed field repairs without highly specialized measuring equipment. The modular architecture meant failed components could be isolated and replaced without complete engine removal. Then came the test that would prove everything. December 7, 1941, changed America's industrial priorities overnight. The country that had been preparing for war was suddenly fighting it on two fronts. The military needed engines, and they needed them now. Not prototypes or experimental designs, but proven, reliable power plants that could be manufactured by the thousands and shipped to theaters where failure meant more than inconvenience. So the Series 71 went to war. The scale was unprecedented. Detroit Diesel ramped production to deliver engines in massive volumes, feeding an industrial machine that had to supply two global theaters simultaneously. The 671, built by GM Detroit Diesel Division under wartime contracts, powered thousands of landing craft and naval support vessels across both theaters, including many Higgins LCVPs. Each engine had to start reliably after weeks aboard transport ships, operate in heavy salt spray and corrosive marine conditions, and provide full power when lives depended on reaching the beach. The modular design that had seemed like elegant engineering became strategic advantage. Supply chains stretched across oceans could stock fewer part numbers while supporting more equipment types. A single shipment of cylinder kits could service marine vessels, generator units, and specialized military equipment, though most wartime trucks still ran on gasoline. Battlefield mechanics could cannibalize parts from damaged equipment to keep critical systems running. The standardized architecture meant training programs could prepare technicians to service any Series 71 application, regardless of configuration. Production numbers told the story of industrial mobilization. Tens of thousands of engines flowed from Detroit factories to support the war effort. They powered industrial machinery and marine craft that sustained the Allied logistics network. They powered generators that kept field hospitals operating and communication centers functioning. They powered the industrial machinery that built airfields in jungles and harbors on foreign shores. The larger 12 V-71 and 16 V-71 powered landing ships, armored recovery vehicles, and heavy stationary generator sets that demanded far more output than a single inline engine could provide. The military didn't just use these engines, they abused them. They ran them without proper maintenance. They operated them in conditions no civilian application would ever see. They pushed them past redline when the mission demanded it. They continued operating under abuse that would have disabled lesser designs. When the war ended, America faced a different challenge, building the infrastructure for a peacetime economy that would dwarf anything the world had ever seen. Laying the groundwork for post-war infrastructure projects, including the interstate highway system, launched in the 1950s, transcontinental freight networks, urban bus systems that could move millions of people daily, and construction projects that would reshape the landscape. Highway construction crews relied on Detroit diesels to power the scrapers, dozers, and haulers that carved roads through mountains and across deserts. Inline engines like the 471 and 671 became common in cranes and smaller earth movers, while larger V12 configurations powered massive off-highway machinery that ran around the clock. These engines worked 12-hour shifts in dust-heavy conditions that tested cooling and filtration systems. They operated at altitude where other engines lost power, and they kept working in heat that melted tires and cold that cracked steel. By the 1950s and 60s, long-haul trucking discovered that engines like the 671 and later the 8V71 could deliver the torque needed to pull heavy loads up mountain grades while returning fuel economy that made transcontinental freight profitable. Urban transit systems adopted the inline 671 in early post-war buses, and later the compact 6V71 in rear-engine transit coaches for buses that needed to start and stop thousands of times per day, operate in stop-and-go traffic that would overheat other engines, and provide decades of reliable service with minimal downtime. Marine applications pushed the engines even further. Smaller commercial fishing boats often relied on the 471 and 671 for their balance of torque and